Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Haseeb Electronics. Friends, in this video I will discuss if our power supply turns on and then turns off suddenly, the fan starts and stops again within no time. This is sometimes becomes very difficult to troubleshoot. I hope so after watching this video and using my technique it will not become difficult. And if you want to adjust the output voltage of any switch mode power supply, any ATX power supply, you can adjust the output voltage. I have this one working power supply. I just connected it to make a troubleshooting procedure, and how you can adjust. Sometime the power supply does not takes full load. Reason? Sometime the output voltage are near to any limit, upper limit or lower limit. So in that case the power supply will start, and after a specific load it will turn off automatically. Let's start. I will show you. This power supply is in working condition, and using this technique, using my practical work, you can adjust the voltage. You can see this time I have switching pulse width modulation, and we can adjust the voltage whatever we want. This ATX power supply, it is using AT2005. This IC, it have pin number 1, that is inverting input, and we adjust. It is non-inverting input, and here is output of this operational amplifier and over voltage protection. What happens? We give a reference on any one pin. We make some adjustment. We give it a fixed reference. We need this voltage. It is a decoded voltage level. Suppose if I apply 2 volt here, that means I need 10 volt on the 12 volt section, and I need 4.5 volt in the output section. Maybe if I apply 2.5 volt, I need 12 volt, 5 volt, 3.3 volt. So this supply will generate pulse width modulation at pin number 9 and 10, and this voltage 9 and 10 from this IC, they will drive this transistor, these two transistors, and they will drive this signal transformer, the smaller one, and it will drive these transistors, and it will drive the PFC transformer. In this case we will take some output. This output will be rectified and filtered, and from these capacitors we will take at output terminals. The same time the same voltage are monitored from these resistors. These are applied to supervisor pins. In this case 2005, we have pin number 3, 4 and 5, and if we are using SDC2921, in that case we have pin 1, 2, 3, they are supervisor pins. Here we have 3, 4, 5. So the function will remain same, just only pin configuration will be changed. So if we know the function, we can troubleshoot any power supply. We must know the function of these pins. Here it is monitoring the voltage. Here the same voltage 3.3. in this IC we apply some reference voltage at pin number 16 or pin number 15, and after completion the cycle, the closed loop, it will monitor the voltage at pin number 16. We applied a reference at inverting input or non-inverting input, and then it will compare at the sense pin, and if the voltage are okay, then it will give a signal to over voltage protection OP out signal. If we see here, pin number 1 and pin number 2 are inverting and non-inverting. In this IC we have pin number 16 and 15, inverting, non-inverting, and we take pin number output at pin number 14. But in AT2005 we take output from pin number 16. If we are using 2003 IC, in that case we have the sense pin -5, -12. These voltage are monitored at pin number 5, and same time it is monitored at pin number 14, 15 and 16 is output. Approximately all the supervisor plus PWM controllers are working same. If we are using TL494, 594, that have some different case, that is stand-alone PWM controller. But this voltage mod PWM controller plus supply supervisor, they are working in the same condition. In normal case, we give a reference at pin number 1. Suppose this supply have some short circuit anywhere. Maybe this rectifier is short, maybe any component is short circuit. What will happen? This supply will turn on and it will stop immediately. Why? It's closed loop circuit, it's fault detection circuit. This circuit will not allow to turn it on. To troubleshoot the problem, we have to turn it on. How we can turn on? In this power supply, what I did, I disconnected pin number 4, 3, 4, 5. Pin number 3, that is V3.3 volt sense line. What is this? Over voltage protection, under voltage protection for 3.3 volts. I disconnected pin number 3 from the circuit. Pin number 4, that is V5. Over voltage, under voltage, input for 5 volts. This is sense line for 5 volts. And V12, this is also input, over voltage, under voltage protection for 12 volts. I disconnected 3 tracks. Here is pin number 1, 2, 3, 4 and 5. Pin number 1, 2, 3, 4, 5. I disconnected 3 pins. When I disconnected from the motherboard, from the PCB, so I disconnected the sense lines, these lines coming to the board, because it is connected through these resistors. These resistors are connected to this sense line. So I disconnected 5 volt, 3.3 volt and 12 volt sense. So this IC is now disconnected from the circuit, from pin number 345. What I did, I applied a stimuli signal. We need 3.3 volt at pin number 3. So I connected one resistor here, one resistor here, 3 resistor to 5 volt SB. This SB voltage are always present in this power supply, this standby voltage. So these standby voltage are always present. This purple wire here, 5 volt SB, it is always present. So we need 5 volt for 5 volt sense line. We need a 4 volt so we apply 12 volt. Actually in the circuit there is 12 volt applied to a resistor network, 40 ohm, 2.6k and 1k. So it gives 4 volt at this pin number 3. This 4 volt will translate that the 12 volt are present. If this voltage will drop, suppose we can say this will drop to 3 volt, So that means the voltage will around 9 volts. If here it will go 4.5 volt, that means this output is increased. So it will proportionally, it will increase or decrease. So this IC will detect that the function is within range or out of range. I divided from a voltage divider network 5 volt SB, that is here, standby voltage, and I connected this line to ground. I connected 3.3k resistor, applied 680 ohm resistor, and applied 1k resistor. This 5 volt I connected directly to pin number 4. This pin 1, 2, 3, 4 number pin is connected directly to this SB, standby voltage. Here we have standby voltage, and I connected 1k resistor. I connected 1k resistor to SB and connected direct 5 volt SB to pin number 4. After 1k resistor I got 4 volt and connected to pin number 5, that is 12 volt input, this pin number 4. And after 680 ohm I got here 3.3 volt and connected to pin number 3. So I connected 3.3, 5 and 4 volt at 3, 4, 5 pins, and the last end of 3.3k resistor I connected to the ground. The PS on command here, green wire, connected directly to ground. So no need to install jumper. So I connected here locally. Now this power supply will go in directly in power on state. At pin number 1, pin number 2, pin number 1, pin number 2, we have input reference. One is input reference, which we set what we need from this power supply, and after switching we take feedback at pin number 2. What is the function, what is the behavior, what is the response of the power supply, we measure at pin number 2. That means it is our demand, it is our demand, and it is the result, the response of this IC, this complete ATX, complete power supply. And at this pin, when this pin and this pin is okay, it will allow to keep working. If these two pins have difference, imbalancing between the both pins, this will stop the function of this power supply. If we come here, if we see this pin number 1, here is pin number 1 is connected to a resistor. Actually this resistor, it is a reference. So I removed this end of resistor, I removed it. 5k potentiometer, one end grounded, upper end plus 5 volt, and the center tape end connected to pin number 1 in the place of this resistor, connected at pin number 1. So pin number 1 will not take reference from this resistor, it will take reference from this potentiometer. One end is connected to, this wire is connected to 5 volt SB, and this line, brown line, is connected to ground, connected to ground. So I applied ground here and positive voltage here. The center tape is connected to pin number 1. So I will generate a reference and we will take output on the output terminal. Let's start and we will monitor the pins. This time I have reference 0 volt at pin number 1, 0 volt, and I am taking 1.3 volt. So if I will increase the reference, I applied 0.386 volt in the reference pin number 1. So in that case I will take output 10 volt, 0.3 10 volt. Now I will increase more, 12 volt, 15, 16. I will adjust up to 17, 18 volts. We can see the pulse width. This time it is switching up approximately 60%. If I will allow it to switch at full rate, that time I will take more output. But before going to above voltage, we can replace the capacitors. We must have to replace the capacitors. The capacitors at the output stage are 16 volt and I am applying 18 volt, and if I will apply the more voltage, the capacitor will blast, it will damage. So to prevent the circuit, we have to replace 1, 2, 3, 4, 5, 6, 7. We have to replace these capacitors, and we have to replace 1 resistor, 2 and 3. We have to replace these 3 resistors. If we will replace these resistors, in that case we can take more output voltage from this power supply. But remember, if we want to take more voltage, in every case the power output or efficiency will remain same. If we will increase the voltage, it will decrease the current. At 12 volt, if you are taking 9 ampere, at 12 volt, if you are taking 9 ampere, that means 12 volt, 9 ampere, that means VN2I 108 watts. And if you are taking 18 volt, at that time it will should be about 5.5 ampere or less. So if you will increase the voltage, because watt and voltage, the current approximately this. I also make some alteration. I connected another potentiometer, 1K potentiometer at pin number 2. This 1K potentiometer, I did not connect this end. I connected one end to ground, 1K potentiometer, and connected directly to pin number 2. Pin number 2, I did not remove any component. Pin number 1 removed, 3, 4, 5 removed, pin number 2 is same. So I connected a potentiometer at pin number 2. This potentiometer is 1K variable. So I connected it to pin number 2 and ground. The center tape pin is connected to pin number 2. So using this potentiometer, we can also increase the voltage. This time I am taking 1.6 volt. I have 2 potentiometers. If I will increase this one, I am taking 3.8 volt. The same time I can use another range. So in this way, this time I am taking output from 12 volt. If I will connect to 5 volt, let's see, 5 volt is giving 1 volt, and 3.3 volt section, that is giving 1.3 volt, and 12 volt I am taking 5 volt. So we can adjust, we can take any output from any circuit, because it will increase gradually. The basic idea of this video is to disable the sense line. Suppose I need 16 volt. What we have to do? 16 volt. I adjusted this potentiometer, and we can fine adjust from this potentiometer as well. We can put these knobs in the panel and we can use as the adjustable power supply. If this video is good for you, like, subscribe and share. If you want to watch my future videos, don't forget to press bell icon button so that you will not miss any new notification from my channel. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.